So this first student is Kathleen Connor, the Community College Summer Fellowship Program. Take it away.
Hello everyone, my name is Kathleen Connor and I will be presenting to you how BMP concentration impacts bone healing. Osteoporosis is a prominent issue in healthcare today. Women spend more days in the hospital for osteoporotic fractures than diabetes, heart attack, or breast cancer. Up to 20% of patients suffering from a hip fracture will die within a year, elderly patients, and there's approximately 8.9 million fractures each year. That's one fracture every 3 seconds. 12 since I've started this presentation, and over 200 by the time I finish. So this begs the question, is there a solution? And our lab believes that BMP2 shows promise to be that solution. BMP2 is bone morphogenetic proteins, and they have been shown to successfully increase bone regeneration. So what is BMP2? BMP2 is a family of proteins that stimulate the differentiation of stem cells into early bone cells. The advantages is that BMP2 has been associated with bone healing without adverse effects in low doses. However, it's also been associated with hypertrophic and ectopic bone regeneration. Hypertrophic meaning excessive, and ectopic meaning bone where it should be. So now that we have a basic understanding of what we're studying, we can get into the research that we've done with it. Our hypothesis was that there's an optimal BMP2 dose that for bone regeneration, which we can discover based on a sensitive dose-response curve. We used the critical defect model to test this. We created 2 critical size defects on the mouse cranium. Critical size meant to demonstrate non-union fractures, which cause serious complications in humans. And then we loaded them with a collagen graft that was loaded with or without BMP2. We then witnessed cellular recruitment and healing and bone formation, and we're looking at specifically the day 10 and day 42 time points. These time points give us an early insight into what cells are being recruited versus how they're regenerating and how the healing is happening at the end. So early and late. We use micro-CT, microcomputed tomography, to scan the bones, and it's essentially a 3D X-ray. You can see there's an untreated sample with little regeneration that's occurred versus a BMP2 treated sample where we can see much more bone formation. And these were all from day 42. With the micro-CT, we measured bone volume, so how much bone is present, and we found that it went up in a semi-linear fashion, as you can see here. The pink triangles represent female mice, whereas the blue triangles represent male. And I'd like to highlight specifically the line above that represents statistical significance. The next thing that we measured was tissue mineral content, and so that's how much calcium is present. This also went up as we increased BMP2 dose. However, when we measured tissue mineral density, so the amount of bone present with a specified volume, we noticed there was a drop at 0.25 micrograms. This indicates that the bone forming is likely to be fragile, and we want to try and find a solution for that. That brings us to my current research. My goals are to identify different treatment types, use clear methodology to assess those changes, understand the process of healing from a cellular standpoint, and identify the populations during bone healing, along with investigating differences in recruitment of mesenchymal stem cells and inflammatory cells based on treatment types. You may wonder how I did this, and that was through staining and histology, which allows for a greater understanding of bone regeneration. I used hematoxylin and eosin, which is a standard for cell morphology, toluidine blue, which demonstrates mineralization, and finally saffron and O, which demonstrates the presence of cartilage. All of these images are from the same sample, but it's been treated with different stains, and you can see, or just be introduced to the different things that are being highlighted. They're all taken at 40 magnification, and they're from a day 10 sample treated with BMP2. So first we'll look at hematoxylin and eosin. Hematoxylin gives nuclear definition and detail, whereas eosin is the contrasting counterstain that gives it the pink color. This gives us a broad insight into the cell types present, so we can take a look at those. Right here you can see the graft material. It sort of looks like tissue paper. If you look in the other corner, there's the MSCs, which are the long, thin, spindly cells right here. We have 2 white blood cells with large purple nuclei, red blood cells, and this one in particular you can see is biconcave shape, which I was so excited when I first saw that. Then we have the bone, which is cut off abruptly because this is where the critical size defect was created and the graft was implanted. Next, we have toluene blue, which shows an affinity for nucleic acids. Affinity means an attraction or a preference for, so it's really drawn to nucleic acids. This gives us insight into degrees of mineralization, what parts are turning into bone, and how quickly that's occurring. If we look at these cells, or this sample, you can see the graft material is white because there's no affinity between it and the dye. We have red blood cells, but they appear turquoise and may not be as easy to see. However, the MSCs have much darker nuclei and are much more pronounced, giving us that insight into the mineralization. And finally, we have the bone, and it's not easy to see any white blood cells, and it's not clear to be able to identify those with this stain. Finally, we have safran and O. Safran and O demonstrates cartilage. I included a fracture slide because our lab is a fracture lab. And you can see the cartilage is bright red in comparison to the blue bone. And this is beneficial because if cartilage was present, it would be very clear to us. And so overall, safran and O gives us insight into the connective tissue present. Here we can see the red blood cells again, which appear turquoise, the MSCs in the corner, the graft material, white blood cells. So now that we have an introduction to the staining that I did, we can get into comparisons and the data I've retrieved from it. At first glance, it may appear like they are very similar and there's no real difference, but if we take a closer look and we know what we're looking for, we can begin to see a change. So on this control sample that wasn't treated with BMP2, you can see the layer of MSCs is very thin above the graft compared to the treated sample, which is much larger. We ended up gathering quantitative data, and on this slide in particular, the area was almost double. When we plotted our results from multiple day 10 samples, we found that it was, with a 0.06 p-value, it was double. Next, since we don't just care about MSCs, we also care about degrees of mineralization. We can look at the toll blue. In this sample, we can see that the graft has been reabsorbed, and the defect is still very apparent because little MSC recruitment has occurred and little bone formation has occurred on the control sample compared to the treated. Finally, we have safran and O, and this gives us insight into molecular activity. We can see here on the control sample, it's pretty uniform in its color, whereas our treated sample, you can begin to see those purple tones, which give us insight into that molecular activity and cartilage formation. So in conclusion, we identified white and red blood cells, MSCs, and bone cells. We found that the graft was quickly infiltrated by clot and immune cells, and that with increased BMP, we see an increase in MSC recruitment visually and quantitatively. I'd like to say thank you to the following for helping me with my project. Without their diligence and patience answering my questions and helping me learn, I wouldn't have had the wonderful experience that I have. And I just am so appreciative of that. And I also want to thank all of you for sitting in on my presentation and allowing me to share my passion for BMP2 and its impact on bone regeneration. Thank you. Any questions?
Don't be shy.
What's your favorite stain?
My favorite stain would be chemotoxin and inducer. I really enjoy being able to study the chemistry behind it because although I love biology and living systems, chemistry is definitely a passion of mine.
In one of the early slides, you showed the dose response curve, and there was a dip.
Right.
Are there any theories as to what causes that dip?
That's why we're doing the research that we are, because we're trying to find further clarity about that. It's quite abnormal because we showed the mineral content and the volume, and those both went up, and then when we measured density, it dropped, which you would think would be a combination of the two graphs. So we're trying to investigate why is that happening and why does that make sense.
But BMP2 is really good on differentiation, right? A lot of the other BMPs are better recruitment. Could it be anything to do with like BMP4, 5, 6, 7? Is there better recruitment BMPs than BMP2s?
Possibly. I don't know the answer to that. I know that my lab works with BMP2 and BMP7, and so we're doing research with those two. And BMP is a broad term for specific families. So we're working with specifically BMP2, which is the family 2. Yes.
And maybe I missed it early on. What is a BMP?
Bone morphogenetic protein, which it aids in the recruitment of MSCs, so those stem cells. And
So when it is applied, it's an injection.
so clinically, it's used in spinal fusion patients,
Okay.
and there's a couple other applications, but we're trying to investigate how we can broaden that application.
Okay. All right.
Awesome. We have time for one more if anyone has one. And if not, great job. Awesome.
Thank you.